Thank you to watching Shoaib Views channel. We are discussing about steam turbine overhauling. This is the part to be in which I discuss more vital points for overhauling, turbine bearing inspection and overhauling. Steam turbine bearings are mechanical components that support a shaft's rotation and linear motion. They are essential for the operation of steam turbines, which are a vital part of power generation. Types of steam turbine bearings. Roller bearings, a common type of bearing for steam turbines. Sleeve bearings, a common type of bearing for steam turbines. Tilting pad bearings, a type of bearing used in larger turbines. The number of pads in the bearing depends on the rotor's weight. Thrust bearings, a type of bearing that supports the axial force of steam and coupling. Plain journal bearings, a type of bearing used in medium turbines. Inspecting and overhauling steam turbine bearings involves several essential steps. Regular inspections should be scheduled based on equivalent operating hours to detect potential issues early. Key considerations include internal inspections of the turbine flow path, shells, and rotors to identify any damage or wear that could lead to major failures. A dedicated maintenance team is crucial for effective overhauling, ensuring all components meet operational standards and safety regulations. It's advisable to double-check specific maintenance guidelines provided by the manufacturer for your particular steam turbine model to ensure the best results. Thrust bearing. A steam turbine thrust bearing supports the axial force of steam on the rotor, keeping it in position and preventing damage. How it works. The thrust bearing is a sliding bearing that uses hydrodynamic lubrication. The bearing has a rotating plate and a series of tilted pads. The pads are made of Babbitt white metal or PTFE. The yellow film between the plate and pads prevents wear. The thrust bearing supports the axial load generated by the pressure difference between the steam inlet and outlet. Why it's important? The thrust bearing ensures the rotor is in the correct position and that the axial clearance is safe. It prevents damage to the turbine rotor and ensures smooth operation. Monitoring. The temperature and axial displacement of the thrust bearing are monitored to ensure safe operation. If the temperature or displacement is abnormal, it should be analyzed and addressed. Inspection and overhauling of steam turbine thrust bearings involves several crucial steps. Start with a disassembly of the bearing to check for bearing metal condition, measure clearances, and inspect the bearing seat in the housing. Conduct thorough examinations of the bearing components and overhaul or replace them as necessary. Also, check the contact surfaces and determine the required shim thickness for tilting pad thrust bearings to ensure proper alignment and function. A steam turbine journal bearing is a type of bearing used in steam turbines to support the rotating shaft by providing a smooth surface for it to spin against, typically utilizing a thin layer of lubricating oil to minimize friction and wear, allowing the turbine rotor to rotate freely within the housing. Essentially, it's a cylindrical sleeve that holds the shaft in place while allowing rotation with minimal contact between the metal surfaces. Function: to support the radial loads of the turbine rotor, preventing excessive movement or vibration while it rotates. For inspecting and overhauling steam turbine journal bearings, start with a thorough inspection based on equivalent operating hours and establish a maintenance schedule. Key steps include dismantling the gland box, removing components such as the governor drive coupling and carbon rings, and conducting internal inspections of the turbine flow path, shells, and rotors to identify potential damage early. It's crucial to document all findings and ensure that all parts are adequately cleaned and lubricated before reassembly. Turbine monitor and safety. Steam turbine monitoring is the process of continuously tracking and analyzing the performance of a steam turbine. This process helps to identify issues before they become failures, and to plan maintenance. Speed sensor, vibration detector. Steam turbine monitoring is the process of continuously tracking and analyzing the performance of a steam turbine. This process helps to identify issues before they become failures, and to plan maintenance. To be continued. Thank you to watching Shoaib Views channel. If you likes my videos, please subscribe my channel, follow, like, and share it.